which is relevant to astral space, is that, of course, astral space going to infinity, how do you characterize the limit points? One way is just to look at the direction. And the source of that was margin theory. So when you worked on AdaBoost, it goes off to infinity. And one way to characterize those directions, in some cases, just by the margin. So, of course, it took many years to go from the original AdaBoost paper, the original boosting paper, and get to the boosting the margin paper together with Peter and others. And so I'm wondering, even though originally when you worked on boosting was purely treated as kind of a training error question of driving the training error down to zero, if you realized when you were doing the original work that would have this huge influence on generalization and creating all of this generalization theory.
Oh, did I realize it originally?
Yeah.
Well, we were always interested in generalization because what we were interested in was proving pack bounds. So, I mean, the boosting question came up in studying pack learning. So, you know, pack learning with high probability, you want to get high accuracy. And so Michael Kearns and Les Valiant asked, what happens if you can only get a little bit better than random guessing in terms of your accuracy? But that was always a question about generalization. So it meant on a test set or for the population, we use those terms then, but and so that was always our interest. And so, so the original boosting papers did answer that. They did it in one of two ways. They either thought about boosting on a fixed training set, but still proving things about generalization, or they also did this analysis that probably most people have not seen, but where you imagine the data coming in a stream from the true distribution, and then you're actually working directly with that stream of random IID examples to prove something, but about that distribution. And so either way, it was proving something about generalization. But the thing is that the bounds we got were always predicting overfitting. They were always predicting that if you train for too long, then the test error will go up, even though the training error is coming down. And so, so when people actually did experiments, they discovered that it tended not to overfit in that way. And so that created this puzzle, like, why is it working? I mean, the discussions were a lot like discussions today of neural nets and so on. It's like, why is it that you have this huge complicated thing that's so much bigger than your data set and it still seems to work? It was the same questions, but about boosting. And so that's where the margins theory came about as a way of explaining why that is. But we were always interested in generalization.
So related question was, so did you expect it to have consequences outside of that exact one? So for instance, Peter, why do I not?
Peter was.
So Peter has this paper from 1990 about neural networks, and that norm of the weights is more important than the cardinality of the weight set. And that's sort of a margin paper giving bounds for networks. So did you expect that it would have consequences outside of, that the idea would have, that the margin theory idea would have consequences outside the immediate algorithm?
Well, like you said, Peter's paper came first, that paper you're mentioning, if I'm not mistaken.
Before the boosting the margin paper,
Yeah.
But it didn't, I mean, it came after your boosting papers.
Yeah, but wait, you're asking if I thought it would have the margin theory would have repercussions outside
If all
boosting?
the original boosting ideas and sort of the genesis of the margin.
I don't know. Yeah, I don't know. I'm not sure I was thinking about that exactly. I was very theoretical, and so I was. It was only when people did experiments that I was like, oh, maybe this actually does something useful. It's kind of sad, but I got through graduate school without ever doing experiments with it, and
that was actually going to lead to my next question. So we've brought up boosting basically every workshop here because every time someone feels backed into a corner trying to justify the role of theory and why theory gets money, at some point someone panics and mentions boosting and SVMs. And I'm wondering if when you were working on, of course, you were working on boosting to a great extent because it's purely mathematical and computational questions, but I was wondering when you started, how much you were motivated by potential practical consequences, and then how this evolved as you worked on it longer and as practical consequences started to appear.
Yeah, well, I think I was mainly interested in the theory side, and I mean, maybe it might have occurred to me at some point that this is really what learning is about, is maximizing your accuracy. So maybe this could be a way of helping to do that. But yeah, honestly, I was mostly interested in these theoretical questions and things like it has consequences for compression. That seemed really interesting to me, that you can use boosting algorithms that you can prove that boosting algorithms will always can be used to compress a data set, and those types of things, and it can be used to prove a certain kind of space efficiency that's related to the fact that it has these compression properties. So I think that was the type of questions I was mainly interested in. I'm not saying that was the right thing. I wouldn't necessarily recommend people to not be thinking about practical consequences, but looking back on myself, I think that was the reality. Yeah, there's what I did and what I should have done. But it was more like, I mean, we were predicting that would overfit. And so it was a surprise when people did experiments and it did not overfit, and it actually seemed to work well.
So two related questions, and I guess I'll move to some audience questions soon. So I was mentioning earlier that you're very good at sort of protecting yourself and finding lots of time to do things you care about, do your theory and do your math, and not really, worry about, for instance, the things we heard yesterday about IQs of all these different tokenized LLMs. So yeah, I was wondering if you could talk a little bit about how actually you protect yourself and protect your time and find ways to do theory all the time.
Yeah, I'm not sure I'm always as effective as I might look to the outside. I mean, there have been times in my life when I did not have time to do research, but I'm in a very lucky place right now at Microsoft that I have the freedom to spend a lot of time on theory, and
I'm unsatisfied because I know the Git log. I mean, I know how many theorems you write a day. So
well, with the astral stuff, I admit that I'm kind of obsessed with it, or I have been, and so it helps that I can't sleep, and at like 4 a.m. I get up thinking about a problem, and that's again something I don't recommend, and I probably would not do by choice. But
I mean, another thing is that even though you've proved more theorems than I have days in my life, you somehow manage every time you go on a train ride to sort of zone out away from all the people like vaping in your face, which you've told me about. And it's a couple times, and you manage to zone out and walk out of every train ride with a new theorem afterwards. Like, how do you maintain this incredible?
Don't listen to him.
Like, how do you?
Exaggeration.
No, I mean the original astral space story was I asked Rob and I were talking one day, and we were saying, okay, so for lots of convex functions, it suffices to minimize them by array, but are there convex functions where you can minimize it in 2 directions? Because we did not know. And if you look in the literature other than the astral space book, there is no example. And then Rob comes back the next day from a train ride and says, hey, guess what? And he has this notepad. And I'm like, what planet am I on? It's 9 a.m. Like, how did you do this? So how do you maintain such mental purity that you can just walk? I mean, I sprinted here to get here on time today. Like, I did not prove a theorem on my way to Simon Institute this morning. Like, how do you do this?
Yeah, I'm not as productive as you say, but I think what's important is okay, so what is effective for me, and I think anybody, is for your heart to be in whatever it is, and to for me, what is effective is to follow my own curiosity um, and to follow my heart, and to do things that I think are interesting and meaningful. And I think that's what it takes is motivation. I mean, there have definitely been times in my life where I was not productive and felt unmotivated, and like anybody.
Maybe share a story about some curiosity how you follow
Oh,
this is so natural for you. And
well, any of the things you mentioned, boosting was a problem posed by Michael Kearns and Les Valiant, and I just thought it was a really cool problem. So I spent a lot of time thinking about it. The astral space, I'm endlessly curious about. I mean, it's like this whole world that we've been working in, not entirely new, as I said before, but definitely understudied. And there's just endless questions that,
just because they were cool.
I'm really interested in.
Just because they were cool.
Yeah.
Like
now, is that the best advice for a young person? I'm not sure.
Maybe it is. Colonel Perceptron,
No.
all these just because they were cool.
I think people have to figure it out for themselves. What how to approach research. But for me, what's worked is to follow my curiosity and my heart.
So if this generic question everyone's been throwing, if you were graduating high school now and you were going to start college, you would just follow your heart. What major to pick?
Yeah, I think so. Yeah, I've had advice. I mean, I love quoting Joseph Campbell, who would say, "Follow your bliss," is the phrase that he would use. I still think it's a good advice. I'm not sure it's always. He would say, if you look at the full quote, he's talking about how if you follow your bliss, it'll open doors that you didn't even know were there. I'd still like to believe that. I'm not sure it's always true, but it's at least worth a try.
So I'll take a few audience questions, then we'll wrap up. I'll hand this to Nati's.
Uh-oh, he's going to beat me
I
up
hadn't even
again
finished
on
the
astral
sentence. I like
space.
it.
I don't know if this is a question, a request for comment, more the question. I wonder if you can comment a bit on the shift in areas. Cult kind of learning theory came out from more TCS, like the learning theory community, and for a time, the ICML, NIRPS, or NIPS at the time, and cult communities were pretty separate, came from different directions, and later on, there are a lot of connections with optimization that was discovered, I think. I don't know. I mean, with other areas and now with statistics. I'm curious if you can comment a bit about, from your perspective, like the history of these shifts and at what points kind of whether there are pivotal moments from that, and also looking forward, which areas do you think will become, or which communities, I'm not sure, will become more tied to in the coming years?
Which communities will be?
Where do you see this going? Like, will there be a merger kind of in the same way that, okay, I mean, I feel like the optimization and learning theory communities, for example, became very merged. Like many people now, I can't tell if they're doing optimization or machine learning.
Mm-hmm.
But that was definitely not the case, like in several decades ago.
Yeah.
So which communities or research areas or disciplines, I'm not sure what's the right term here, do you think we'll see more of such mergers or interactions with, or will become important, or maybe separations?
Yeah.
I'm not sure, especially versus statistics also in other areas.
Yeah, well, it's certainly true. The field has certainly changed. Matus sent me a much longer list of questions to look at it, which got me thinking about how much the field has changed. And it's true. It used to be much more discrete, much more theoretical computer science, a lot of work on things like Boolean formulas that nobody thinks about now.
Oh, we do, yeah.
Oh, okay, oops.
Please.
Not as many people think about now. Is that true? Uh-oh. Um, but as so so where's it going? It's hard to predict. I think what's benefited the field is when the field has started talking to other fields, like when the Coles community started having joint conferences with ICML and people started publishing back and forth. I mean, that was a new thing. I remember the first time I submitted a paper to ICML, that was a big deal for me. And I was really nervous about it. And, you know, is it going to get in and giving the talk? And because they really felt like separate communities, which you wouldn't even think about now. And I think what's really helped is when the communities start talking to each other. And I'm not sure I can really predict where it will go, where that will go, but I think what helps is communication between them for bringing them together. Yeah, I remember going to a talk many years ago where a person from the optimization community was giving a talk and saying, "Oh, I really think optimization could help machine learning," and gave examples, and this seemed like such a new idea at the time. So yeah, I don't think. I think that was it. Yeah.
Maybe one more.
So I'm going to actually follow up on your question. Like this question of navigating what research question you want to pursue, right? Like we all live, well, many of us live in this world where we're pursuing citation counts and tenure and grant money and all this other stuff. And the story that you just spun, I'm not sure what the past tense of that is, was that you kind of didn't care and you got lucky. Is that a proper interpretation with boosting, right? Like this was something important.
Yeah.
And it just caught on.
Well, I mean, I did care about publications for sure. And,
so, okay, right.
Yeah.
That's interesting. That is not pure curiosity, right?
That's true.
So,
that's true. Very nice.
It's just a fact, right? Like,
yeah.
The papers I would write if I were just doing curiosity versus if I'm trying to raise my stature in the field, those are different sets.
Yeah. No, you're right.
So the question I was really trying to drive at was, have those sorts of economic and survival pressures ever threatened your ability to pursue that curiosity as faithfully as possible? And if that ever did happen, how did you negotiate that complication and get back to curiosity?
Yeah. Well, so I mean, it's hard. So first of all, let me acknowledge what you're saying. That's a good point. I mean, yeah, sure. I was definitely interested in publishing papers like anybody else. But it was kind of still, for me, I need the other part also. I still need to have the motivation is what I found with myself that, I mean, I've been pretty lucky in my career that I've been able to get a job with doing that, and not everybody, I know it's not always like that by any means, and I've also had the problem of going for periods where I did not feel motivated and really had a hard time finding something that I was excited to work on. Also, that's been more of a problem for me than economic. I mean, I guess I did have a close shave with layoffs, but it was okay. But that was just AT&T craziness. AT&T years ago had major layoffs that affected many people in my lab, and I ended up, even though I wasn't laid off, I ended up leaving as a result of that. But that was, yeah, the company undervaluing research and undervaluing machine learning. The head of the new lab specifically, no, well, no, I take that back. No, that was a different time. I was going to say he didn't like machine learning at all, but that was somebody different. But yeah, so.
Thank you. Well, let's think, bro.
Okay, so